2.3 Nomenclature of inorganic compound. First, we see the definition of cation. Cation, ion with a positive charge. If a neutral atom loses one or more electrons, it becomes a cation. For example, sodium atom has 11 protons and 11 electrons. When it loses an electron, it becomes sodium ion. Sodium ion has 11 protons and 10 electrons. Anion, ion with a negative charge. If a neutral atom gains one or more electrons, it becomes an anion. For example, chlorine atom has 17 protons and 17 electrons. When it gains electron, it becomes chloride ion. Chloride ion has 17 protons and 18 electrons. Notes: the proton number is the nuclear charge and also the number of electrons in a neutral atom of the element. For neutral atom with zero charge, number of proton equal to number of electron. For cation with positive charge, means atom lost electrons, number of proton greater than number of electron. Anion with negative charge, atom gain electron, so number of proton less than number of electrons. The most important rule of naming a compound is that the name of a substance should be clear. So, I will explain about IUPAC nomenclature for cation, anion, and also salt. Nomenclature of cation. First part, metals ion with one stable oxidation state. Metal from group 1, group 2, and group 13. Naming of the metal followed by the word ion. For example, Na plus is sodium ion, Al3 plus is aluminium ion, Zn2 plus is zinc ion. Second part, metals ions with more than one stable oxidation state. Metals from block D and block P. Naming of the metal followed by Roman numerals corresponding to the oxidation state enclosed in brackets. For example, Cu plus is copper in bracket 1 ion, while Cu2 plus is copper in bracket 2 ion. Another example, Fe2 plus is iron in bracket 2 ion. Fe3 plus is iron in bracket 3 ion. The third part, cations formed from molecules composed of non-metal atoms have names that end in -ium. For example, NH4 plus is ammonium ion, H3O plus is hydronium ion. This is an example of common cations. In this table, they are listed by charge. Certain elements such as copper iron, tin, and others exhibit more than one oxidation number. In these cases, the name of the element is followed by the oxidation number in Roman numerals in parentheses. Naming for an ion. First part, names of monoatomic anions are formed by replacing the ending of the name of the element in "-ite". For example, H negative is hydride ion, O2 negative is oxide ion, and 3 negative is nitride ion, and Cl negative is chloride ion. A few polyatomic anions also have names ending in "-ite". For example, OH negative is hydroxide ion, Cn negative is cyanide ion, O2 negative O22 negative is peroxide ion. Second part, names of an ion of oxo acid, oxygen-containing acid, and in "-ate" and "-ite". The "-ate" is used for the most common of representative oxyanion of an element. The "-ate" is used for an oxyanion that has the same charge but one oxygen atom fewer. For example, NO3 negative is nitrate ion, and O2 negative is nitride ion. Another example, SO42 negative is sulfate ion, and SO32 negative is sulfide ion. The third part, an ions derived by adding H positive to an oxyanion are named by adding as a prefix to the word hydrogen or dihydrogen. For example, HCO3 negative is hydrogen carbonate ion. For H2PO4 negative is dihydrogen phosphate ion. This is example of common anions. In this table, they are listed by charge. Nomenclature of salt. Salts are ionic compounds which, when dissolved in water, break up completely into ions. They arise by the reaction of acid with base, and they always contain either a metal cation or a cation derived from ammonium ion. So how to give name of salt? Salts are named as follows. First, you must put name of cation, space, and name of anions. This diagram shows how to give the compound name. Let's try example 1. Write the formula for potassium bromide. First step, it is found that potassium has an oxidation number of positive 1 and bromide has an oxidation number of negative 1. Writing the symbol of the positive element or polyatomic anion first. So the formula is KBr. Second step, the algebraic sum oxidation number is positive 1 plus negative 1 is equal to 0. Thus, the positive and negative oxidation numbers match, and the formula of potassium bromide is correct as written above. The formula of potassium bromide is interpreted to mean that a molecule of the compound contains one atom of potassium and one atom of bromide. Second example, write the formula of iron 2 bromide. First step, it is found that the oxidation number of iron is positive 2 and the oxidation number of bromide is negative 1. If the formula of iron 2 bromide is written as FeBr. Okay, go to the second step. The algebraic sum of oxidation numbers of the elements in this formula is positive 2 plus negative 1 is equal to positive 1. There is an excess of positive oxidation number and the addition of a second bromide ion will be needed to make the sum 0. The algebraic sum of the oxidation number now is positive 2 plus 2 times negative 1. The total is equal to 0. This formula, as written, is in an inconvenient form since the formula of bromide appears twice. In order to simplify the formula, a subscript is used to indicate the number of bromine atoms required. In this example, 2 bromine atoms are needed, so the proper formula for iron 2 bromide is written as FeBr2. The table shows formula of salt and their name. For example, RbBr. The name of salt is rubidium bromide. Next example, FeCl3. The name is iron in bracket 3 chloride. NaNO3. Sodium nitrate. FeSO4. Iron in bracket 2 sulfate. In neither cases, hydrate salts are named as follows. Name of salt, space, multiplying prefix hydrate. For example, CuSO4 5H2O. The name is copper in bracket 2 sulfate pentahydrate. Second example, AlKSO4 2 12H2O. The name of salt is aluminium potassium sulfate dodecahydrate. Okay, let's try an exercise. Name the following compound. We will discuss how to give the name for PbI2. PbI2 comes from Pb2 plus, lead 2 ion, and I minus iodide ion. So, the name of PbI2 is lead 2 iodide. Second example, FeSO4. It comes from Fe2 plus iron 2 ion and SO4 2 minus sulfate ion. So the name of the salt is iron 2 sulfate.